Hello, this lesson is about factoring quadratic trinomials when a equals 1. So, a quadratic expression, because before we can start factoring quadratics, we probably should know what that is simply an expression whose highest degree is 2. A degree is the highest exponent in an expression, an equation, or a function. So if you look through these, you'll see that this first one is a quadratic expression. It's not equal to anything. A quadratic equation might be equal to 0 or 10 or some other number, but it has an equal sign within it. And a quadratic function is always f of x equals or y equals this form of ax squared plus bx plus c. We call this standard form. So it's going to be important when you're factoring to make sure that your expressions are in standard form. And all through the rest of this unit, and this unit will last a long time, it all has to do with quadratics. So we're going to start by learning how to factor. So if we had an expression like x squared plus 12x plus 35, in order to factor this, in order to break it into parts, the question we ask ourselves are, what are factors of 35 whose sum is 12? So sometimes you're going to know off the top of your head, right away you're going to say, I know what that is. If you don't know, then start by listing factors of 35. So for instance, 1 and 35, 2 does not divide evenly into 35, 3 does not divide evenly into 35, 4 does not divide evenly into 35, but 5 goes in there 7 times. And then you could say, does 6 go in there? Nope. And at that point, we're back to 7. So we know we've listed all of our factors. So what we're going to say is okay, the factors of 35 that add to equal 12 are 5 and 7. So we can rewrite this expression as x plus 5 and x plus 7. Or you could do the opposite. You could write x plus 7, x plus 5. Either way, those are the two factors, the two pieces that you need in order to make x squared plus 12x plus 35. And you can always check this. That's the great thing about factoring, is it's easy to check back and forth. You could just double distribute like you learned way back in Algebra 1. You could say, okay, x times x is x squared, x times 5 is 5x, 7 times x is 7x, and 7 times 5 is 35. When you combine like terms, you get what we started with. Let's look at our next example. Example 2. We want to ask ourselves, what are factors of 24 that add to equal negative 10? So similar to the last problem, we're going to say, okay, let's see. What goes into 24? 1 and 24, 2 and 12, 3 and 8, 4 and 6. But none of these would add to be negative 10. So we know that they're both going to need to be negative numbers. Otherwise, they wouldn't multiply to be a positive and add to be a negative. So once we get to this point, we just look through our options and we say, which of these multiply to equal 24 but add to equal negative 10? This last one right here. So the factors we're going to use are x minus 4 and x minus 6. Okay. For this next one, we're going to say we're looking for, again, we're looking for factors of negative 24 that add to equal positive 5. So 24. Okay, to multiply to equal negative, one needs to be negative and one needs to be positive. So negative 1 and positive 24. Or negative 2 and 12. Or vice versa. Or negative 3 and 8. Or negative 4 and 6. And then you go through these and you just say, which of these would add to equal a positive 5? So add to equal positive, the larger number has to be positive. And then they have to add to equal positive 5. So the answer to this is x minus 3, x plus 8. So looking at this one, in your Ed puzzle, answer this question. In the example 4, we are looking for factors of what that add to equal what? Or in other words, we are looking for factors of what number with a sum of what number? Okay, so now that you've had a minute to think about that, our factors of 10 is not a very long list. These are really the only numbers that multiply to give us negative 10. So then you go through this list and you say, okay, which of these would add to equal negative 3? So I know my negative number needs to be have the bigger absolute value. It's going to be that one. So x plus 2, x minus 5. This next one looks a little silly, but really, there's no middle term. So what we're trying to figure out is, what are factors of negative 36 that add to equal 0? So in order to add to equal 0, our two numbers would have to be opposites. So what are factors of negative 36? Just going through this list in my head, I divide by 1, then I divide by 2, divide by 3, by 4, 5 doesn't go in there, but 6 does. And then 7 doesn't go in there, 8 doesn't, and we're back to 9. So if we look through all of these, none of these numbers, if we're going through this list, except negative and positive 6 would add to equal 0. So our answer ends up being x plus 6 and x minus 6. This example actually has a special name. It's called the difference of squares. So the difference of squares says that if you have a squared minus b squared, it's always going to be a plus b, a minus b. In other words, it's going to always be the square root of this first part, x, plus the square root of the second part, so 6, and then the square root of the first minus the square root of the second. If you don't remember difference of squares, you're fine. You could go back to just what we've been doing. What are factors of negative 36 that add to equal 0? It'll work every time. The important thing to note about this, however, is that there is no sum of squares. In other words, if you have x squared plus 36, it wouldn't be factorable at all. There's no way that you could have this a factor of positive 36 that adds to equal 0. Just an important thing to remember. So I'm going to give you a few minutes here And I want you to try each of these questions. If you don't have some paper, you might want to pause the video to get some paper. You're going to do them out, and then the Edpuzzle will ask you to answer each of the following questions. Now that you've had a few minutes, we're going to go over each of them. So the answer to the first is x plus 3, x plus 4. Or you could have x plus 4, x plus 3. The answer to the second is x plus 3, x minus 2. Or you could have the opposite, but the 2 has to be negative, or you wouldn't get a sum of positive 1. In the third example, it's going to be x minus 4 and x minus 2. Again, the factors could be reversed. X minus 6, x plus 4. Again, the factors could be reversed, but the 6 has to be the negative value, the 4 has to be the positive value. This is going to be x plus 3 and x minus 3. And this last one, it's not factorable. So sometimes you'll see the phrase not factorable, or sometimes you'll see the word prime written. In other words, it can't be broken into factors. So I've got a challenge problem here at the end. It's a fancier quadratic. It has both x's and y's. This often makes kids panic, but you don't need to panic. You're still breaking it down like you were before. What are factors of 6 that add to equal 5? So factors of 6 that add to equal 5, 1 and 6, negative 1 and negative 6, 2 and 3, negative 2 and negative 3. So we know out of those options, it has to be 2 and 3. So we start by saying, okay, x plus 2, x plus 3. But in order to get 5xy, in order to get 6y squared, each of these last terms needs a y added to it. Looks a little different, but it's really the same idea.